We're learning about in this section are side, 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 and side, angle, side. Side, 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 and side, angle, side. There's going to be 4 total, really 5, but 4 main ones, to prove 2 triangles are congruent. And the first 2 are in this section, side, 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 angle, side. And what that means is if I'm told that all 3 sides of a triangle are the same measure as all 3 corresponding sides of another triangle, it doesn't matter what the angle measures are. That's all the information I need to prove those 2 triangles are congruent. Once I prove those 2 triangles are congruent, now I can say all those angle measures are congruent or are equal. So as an example, if I'm given this information, I can then say triangle ABC is congruent to triangle, and I have to be careful, I've got to get it in the right order, but it would be DFE. Because AB and DF are equal, DEF is actually what it is, DEF. Because AB and DE are congruent, AC and DF are congruent, AC, DF. Do you see how the order of the letters match up? Okay, so I can write this congruent statement, and once I know that statement is true by side, 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 which we can just write if the pen would work, side, 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 anyway, side, 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 I can then say that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F, even though it wasn't given to me, because I proved these 2 triangles were congruent. With me so far? The next one is the side angle side theorem. And the side angle side theorem, or postulate, if I could write these, make it D, E, F. If I'm told one angle in one triangle is equal to one angle in the other, and the side, the 2 sides that are around that angle are equal in measure, I can prove these 2 triangles are congruent. It's really important, though, that the angle that you're given is the included angle between the 2 sides. Okay? If I'm told that this side and this side are equal, that's not the side angle side theorem, even though it's side angle side. That angle has to be the included angle between the 2 most adjacent sides. Follow me? Hopefully. Okay. So now I can say triangle ABC is congruent to triangle, and I've got to get it right, DEF by the side angle side. That's why we just write that side angle side postulate of congruence. Okay. Once I know that, I know BC and EF are congruent, even though it wasn't given to me. I know angle B and angle E are congruent, and I know angle C and angle F are congruent, even though that wasn't given to me, because I was able to show that those 2 triangles are congruent by side angle side. Okay, so we're learning the ways to prove 2 triangles are congruent with just a little bit of information that we then can use to prove other parts of those triangles are equal to their corresponding part once we know they're congruent. Does that make sense? Okay, so you're going to have some proofs in this section on big ideas. And one of them could be, given this information, prove angle C is equal to angle F. Well, the first thing you have to do is prove the 2 triangles are congruent. And then you could say C is equal to F. And this is an important reason for congruent triangles. Once you prove 2 triangles are congruent, if you're trying to prove something else and that those triangles are equal, like C is congruent to angle F, the reason is, and this is how we shorten it, corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. And what that means is, if these two triangles are congruent, angle C and angle F are corresponding parts of that triangle, right? C correlates to F. It's corresponding. It's a corresponding angle. So if I want to prove that C is congruent to F, after I've proven these triangles are congruent, my reason is because corresponding parts of congruent triangles are congruent. Okay? You could write it, the whole thing out, corresponding parts of congruent triangles are congruent, or just shorten it to CPCTC. But you're going to use CPCTC a lot in proofs of why one angle is equal to another, why one side is equal to another. And it always starts with using whatever information you're given to prove the two triangles are congruent, and then you can prove those corresponding parts are congruent using this reason. If you prove them congruent triangles, the corresponding parts must be congruent. Okay? It's not hard, it's just logic. You've got to prove the triangles are congruent before you can prove the corresponding parts are congruent. Okay? Let me go to, if it would let me. The videos, which hopefully you watched, I put them here for a reason. If you don't understand proofs and how to do them, don't come in and say I don't get it if you haven't watched the videos. The videos go through how to do these proofs. Okay? So that's your first place to go. If after you watch them you don't understand, then ask me. But don't just come in and expect you sit here and you're supposed to just know by osmosis without doing any work on your own. Okay? These videos go through how to write two-column proofs using CPCTC once you prove the triangle's congruent. So if you're not understanding how to do that and you haven't watched them, go back and watch them. All right? Here's an example of a proof in the reading of two triangles. We're given that AB and DE are congruent. I'm going to draw this. Maybe. I've got to connect them somehow. So I have I don't know what they labeled them as. A, B, C, D, E. Making a mess. And they say that this is congruent to this. And what we want to prove is that the two triangles are congruent. And we're also told that C is the midpoint of AE and DB. C is the midpoint. So AB is congruent to DE, and C is the midpoint. And I'm going to go a little further. I want to say prove angle D is congruent. Which way do I want to go? C is the midpoint of AE to angle D, angle B. So we're going to talk through how to do a proof. Okay? I'm given these two triangles. I'm told that AB and DE are congruent, and I'm told that C is the midpoint between A of AE, even though the drawing doesn't look like it. Okay, before you even start a proof like this, talk yourself in your head through what you need to get to. Okay? We know in this section that we've learned side, 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 and side angle side of two ways to prove two triangles are congruent. I have been given one thing for sure, two sides. Right? Two sides are equal. But there's no proof that says side by itself is enough to prove two angles are congruent. So I either need to find two other sides, or I need to find an angle and a side where that angle is included. Okay? The other piece of information that I was given is that C is the midpoint. So right away, I can mark this drawing up like this. That's what midpoint means, right? It breaks that segment into two equal parts. So I know AC and CE must be congruent because of what was given to me. C is the midpoint. So now I have a side and a side. What can I do now? I want to make sure I've written this right. C is the midpoint of AE and DB. So now I know this is true, right? So now I have side, side, side. Do you see that? Okay, so now we know, we've talked it through, now we've got to actually write the proof out. And I think in big ideas, you have to like pull reasons up, like we did in the proofs of chapter 2. You know what I'm talking about? You have to match the reasons and the statements in the proof. You don't have to write it out yourself, but this is how you write it. First thing you're going to do, if my pen would work, is rewrite the given. Come on. AB is congruent to DE. What else is given? C is the midpoint of AE and DB. Of AE and DB. Okay, and the reason is given. Remember, you always rewrite the given. Okay? Now I could say, in one step, I could say that AC is congruent to EC and BC is congruent to DC. Why? What's that? Okay, C is the midpoint. It was given. But what's the reason those two are equal? Definition of midpoint. Definition of midpoint. Okay? I'm going to move over because I think I'm at the bottom. So 3. I've now proven AB is congruent to DE because it was given. AC is congruent to EC. BC is congruent to DC. So now I can say triangle, and now we have to be careful. What is? So let's just write ABC because that order doesn't matter. To what? DCE. Good. Everybody see the difference and why it's really important to concentrate on what's equal to what? Yeah. To triangle DEC. And the reason it's DEC and not DCE, if I'm going ABC, AB and DE are congruent to each other. Okay. And the reason, which I'll write over here, is side, side, side. That theorem or postulate that says if 3 sides are congruent, the triangles are congruent. Now, my goal is to prove that D and B, well, I should have made that D and A. D and A are congruent. It should have been D and E, though, shouldn't it? A, B, C, D, E, C. A and D must be congruent. But A, B, C, it should be E, D, C, shouldn't it? If I say A, B, C, I'm going from the side with 1 to the side with 3.
So it's A, C, B?
So it should go E, D, C. Everybody see why? Now, I can prove that D and B are congruent because, look, B is the second letter, D is the second letter. So now I can say angle D is congruent to angle B, and my reason is corresponding parts of congruent triangles are congruent. Now that I've proven these two triangles are congruent, all the corresponding parts are congruent. And B and D are corresponding in that triangle. Okay, so just an example of how you do a two-column proof using side, 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 or side, angle, side. The side angle side, again. Huh? Oh.
As it definitely proves.
Oh. The side angle side, again, there are proofs for videos to watch. And there's also examples. Here's a two-column proof to prove angles are congruent using side angle side. And looking at this one, if all we're given on this one is that C is the midpoint, do you see these two triangles?
No, I can't see.
They're basically the same two I just drew. But what I'm not given this time, I could erase it. Same two triangles, but now this is all that I'm given. C is the midpoint. So I have a side and a side, side and a side. So I have side, side, but I either need another side to be equal or an included angle. So what angle is included between these two sides? It's those two, right? Why are those congruent? It wasn't given to me. Vertical angles.
Is that what you say, definition of vertical angles?
Well, what you would do is you would start with what's given, that C is the midpoint. Then you would prove that those two sections of the triangle are congruent using definition of midpoint. Then you would say these two angles are congruent, definition of vertical angles.
Okay.
Then you could say the two triangles are congruent, side, angle, side, making sure you write it the correct way. And from there, you could prove this angle and this angle are equal, or this angle and that angle are equal. Okay, it's just a process of first proving the triangles are congruent and then using that knowledge to prove corresponding parts of those triangles are congruent. And maybe I'll be able to get into my next page. I swear. Okay, so let's go through the textbook check.
You're serious? Is you like that Mexican mustache?
And this is 4-3. If you're given two triangles with equal side lengths, you must also be told that all the angles are equal in order to say those two triangles are congruent. False. As long as all the sides are equal, you can use side, side, side to prove they're congruent. So that's false. These two triangles are congruent using the side, angle, side postulate. Okay, we've got one true, I've got one false. Why do you think it's true? Okay, so we have two sides and an angle, but what's important that that angle is between? It's got to be right adjacent to those two sides. It's got to be the included angle between the two sides you're given, right? So this side, and this side have to be the ones that are equal for it to work. Does that make sense? Okay, it's an easy mistake to make, so just pay really close attention when you're given information. That angle, in order to use side, angle, side, it has to go in that consecutive order, side, angle, side. It can't be any side, any two sides in an angle. It has to be the angle that's between the two adjacent sides. Okay. What additional piece of information why? What additional piece of information would you need to prove these two triangles are congruent using side angle side? We're given one side and an angle. What other piece do we need to prove that these two triangles are congruent? Our choices are that AB is congruent to LK. Well, that's not a side that's between, or that's on the other side of the angle. Well, we're given the angle, so we need a third side.
It's the last one.
It's BC is congruent to KM. That side is congruent to this side. I know it's hard to see from there.
Okay, it's not the last one.
No, but it's the side. Yep.
I didn't get question 2 right, but I got that one.
Good. Question 4. Below is a true-false question at the end of one of the videos. True or false? If you want to use SAS congruence to prove true triangles are congruent, as long as you know that two sides of two triangles are equal, and one angle from one triangle is equal to one of another, that's enough information. Why false? Because it says as long as you know two sides are equal to two sides of the other triangle, and one angle is equal to the other angle, you can use it. Yeah, that angle has to be included between the two for it to work. It's not just any two sides. Okay, and then question 5, when using the distance formula to prove two triangles are congruent in the coordinate plane, you would use the side angle side postulate. What does the distance formula tell you? It's a good question.
Oh, distant formula? Oh, sorry. Square root of
I know what it is, but what does it tell you?
between.
Like if I have a triangle in the coordinate plane,
Oh, between a line. 2 lines.
I have this triangle, and I'm going to use the distance formula. Once I've found the distance of all the sides, which postulate would I use? Side, 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 or side angle side, if I had two of them. And I'm trying to prove they're congruent. And I'm using the distance formula. What postulate will I use once I've figured out if the sides are equal? Yeah, side, side, side. The distance formula won't tell me anything about the angle. Right? So you will have the opportunity in this practice set to also prove two triangles are congruent in the coordinate plane by using the distance formula and finding the side lengths of each triangle and showing that because the 3 side lengths are the same, the triangles are the same. Or maybe one side length isn't the same as another and therefore they're not congruent. But you'll have to use the distance formula to prove that. Okay? Okay. This is side, 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 side angle side, section 4.3. So I believe CK12 is open. If not, tell me. And I think Big Ideas is there as well.